Please state your name for the record.
Greg Garrison.
And you're a principal in a company, correct?
Yes.
And what's that company?
It's Oilfield Testing and Consulting.
And it appears, sir, that you were hired your company at least was hired at some point to do some testing on behalf of the Joint Investigation Team with regard to the cement slurries from the Macondo well, is that correct?
Yeah.
Now, were you involved in either the testing itself or supervising the testing that was performed?
Yes.
Okay. And with respect to the testing, were there specific protocols, testing protocols that you followed?
Yes.
And who provided those protocols to you for the tests?
The JIT.
I want to start by following up on some things that you discussed with BP's counsel. Just to step back a little bit and understand the report that you prepared at Exhibit 5937. It's my understanding that you used, with one exception, and that exception being the Mach 4 slurry, that all of the other slurries you used were on samples that did not come from the Macondo rig, correct?
That's correct.
Okay. And the Mach 4 sample, however, was provided as rig sample that had been sequestered by Halliburton and given by subpoena to the U.S. government and then provided to you, correct?
That's correct.
Okay. Now, prior, when you were setting up the samples or the testing that you were going to do for the JIT, you had originally contemplated to prepare at least 8 Macondo slurry samples, correct?
Yes.
Okay. But in the end, you ended up just testing an unset foam stability test with the Mach 4 slurry, correct?
Yes.
And the other one was there was an attempt to conduct a set foam stability test. They got terminated after 48 hours, correct?
Yes.
Other than those 2 tests, none of the other testing that you did and reported in Exhibit 5937 were on rig samples from Macondo, correct?
Yes, that's correct.
And indeed, all the other ones came from lab stock or stock from Halliburton of materials that were labeled the same way, but did not actually come from the blend that was sent out to the rig. Is that correct?
That's correct.
Now, if we could go to I'm going to call it your main test reports, Exhibit 5937. That's the JIT Macondo well testing document.
Okay.
Now, sir, if you wouldn't mind open to page 34.
34.
And with a few exceptions, because the only tests of which you performed that used actual rig slurries were with respect to the Mach 4 slurries. I'm going to focus on those first, okay?
Okay.
Now, are you familiar with the weigh-up sheets in this case? I'm sorry, are you familiar with the weigh-up sheets that were generated by OTC when conducting these tests?
Yes.
And your technicians are trained to write indications of instability on the weigh-up sheets when they observe them, right?
Yes.
I'm going to ask you to please apply this exhibit sticker, Exhibit 5940, just above that Bates number, if you don't mind.
Sure.
Now, can you confirm for me, based on the slurry design line, that this is in fact the Macondo cement sample, the Mach 4 sample?
Yes.
Okay. And so this is the weigh-up sheet that's associated with the unset foam stability testing that you did on the
Right.
Mach 4 slurry, right?
Right.
And there is a comment there, and I'm going to read it. You tell me if I read this correctly.
Go ahead.
This is a technician comment, correct, in handwritten form?
Yes.
It says no channeling noticed, right?
Right.
6 milliliters void, space, bubble breakout dash minor,
Okay.
right?
Mm-hmm.
Does that indicate to you that the technician found that there was, to the extent there was bubble breakout, that it was minor?
Yes.
And it certainly isn't what you would call excessive, right?
Correct.
Are you familiar with the guidelines in API for determining the instability of foam slurries? The qualitative observations, for lack of a better word?
Yes.
Sir, could you please open to page 10? It's section 9.3.4 of
Section-
API 10b4.
Section 10?
Right.
Page 10?
Yes, sir.
Okay.
Down there at the bottom, there is a section that says signs of foam instability, correct?
Yes, sir.
And it lists it. It says more than a trace of free fluid, correct?
Yes.
Now, you indicated on your test results that you saw no free fluid with respect to the Mach 4 slurry, right?
Yeah.
Okay.
That's correct.
And it says bubble breakout noted by large bubbles on the top of the sample, right? That's what API says.
That's what API says, yes.
And you testified earlier that you didn't see any larger bubbles, correct?
Right.
It says excessive gap at the top of the specimen, minor meniscus effects are normal, correct?
Yes.
Now, you indicated that you can't see any gap in figure 18 of your report,
Right.
but that you thought that there was a gap, a minor gap, right?
Right.
And you said it was a gap that you said certainly wasn't an excessive gap, right?
Right.
All right. You didn't see any signs of density segregation or settling, did you?
No.
Okay. And you didn't see any large variations in density from top to bottom, and of course that would be set cement. You can't do that here, right?
Not in this particular test.
In fact, none of the indications of instability that are set forth in 10b4 did you observe with respect to the unset foam stability test in the MAC 4 slurry, did you?
Could you repeat that one more time?
Yeah, all of these things that we just went through.
Yes.
These API criteria of what constitutes an unstable foam slurry.
Yes.
You didn't see any of those, did you?
In the liquid, yes, this is what we saw.
Excuse me?
No, in the foam stability test.
In the unset
Yeah, in the unset. Yes.
foam stability test,
That's correct.
you didn't see any of these indicators of instability, did you?
That's correct.
I'm sorry, you did not see any of the indicators of instability set forth in what we just read in API, did you?
Right. That's correct.
So you found it was mixable.
Yes.
You found that a vortex was created when you blended it.
Correct.
You found that it foamed in 15 or less seconds.
Correct.
All right. You found that the density of the slurry after you mixed it was, or the specific gravity was 1.79, right?
Correct.
And you did your calculation, and you found out that the density of that slurry was 14.9 ppg, correct? And that's what, 0.4 from target?
Yes.
That's 0.4 ppg away from the target density of 14.5, right?
Right.
You found that there was no settling. You found that there was, right?
Right.
You found that there was no free fluid, right?
Right.
And the bubble breakout, even though it just indicated as a yes here, you said was minor and didn't rise to the level of the indications of instability set forth in API 10b4, right?
Correct.
Now let's talk about the set foam stability test that you conducted. And I think, well, there isn't any data because you didn't finish the test, but I'm looking at page 39 of your report, and that's exhibit 5937 still. Now my understanding is, just forget about all the foam stability tests above it. I want to look at the MAC 4
Okay.
set foam stability test results. You have an NA across, meaning you didn't obtain any data for it, right?
Yes, that's correct.
And there's a note at the bottom that says the MAC 4 Macondo samples did not set hard during the 48-hour curing period, and therefore could not be tested for this particular part of the testing protocol, right?
Correct.
Who told you that the curing period or the setting period was 48 hours, or was to be 48 hours?
The JIT.
Did the JIT tell you that that was contrary to API testing protocols?
No.
Okay. You agree with me that the reason you do a set foam stability test is not to see if something will set up in 48 hours, but rather to see after it sets whether it's stable in the set form.
Yes.
And again, for the record, this is API recommended practice 10b4. I'd like you to look, sir, at section 9.3.2. It says stability of set foam cement slurry. Tell me when you're there.
I'm there.
Can you read for the record the first sentence, please?
Check the foam cement slurry stability by curing samples until they are set and determine the density gradient throughout the sample.
So this instructs that this test is properly conducted by allowing the cement to set not for a 48-hour period, but rather until it's set, correct?
Correct.
So if we were following proper API protocol in the set foam stability test, you would have allowed that Macondo 4 slurry to actually set before you could dissect it, trisect it, whatever you do, and determine whether or not there's uniform density on top and bottom, right?
That's correct.
Okay, but that is not the protocol that JIT asked you to follow here, right?
That's correct.
Just circling back, there were only 2 tests performed on the unset, or on the Macondo slurry. The unset foam stability test, which you say actually indicates that the unset foam was stable, right?
Yes.
And then the set foam stability test, which wasn't run in accordance with API and never actually was allowed to finish as API would have specified, right?
Yes.
And so we don't have a stability result, or we don't have any data about the stability of the set foam cement because the test was actually prematurely terminated as per API.
Objection.
Is that fair?
That's fair.
I wanted to go, if you would, do you still have a copy of your report? It's at exhibit 5937. Actually, I'm sorry, before we do that, let's go to Exhibit 5939, the 60% foam quality, foam stability test that BP proposed.
Okay.
Okay. Now, there was a period of time when you were actually setting up your proposed protocols, and there was some communication. I'm not getting into the contents of the communication with the JIT, but there was a period of time in which you were actually working at developing the protocols that you would use for testing, right?
Correct.
And at any time during that time, did you or the JIT ever propose to do this 60% foam quality, foam stability testing?
No.
And I think you indicated earlier that this is not an API test, is it?
The
60% foam quality test.
No, it's not.
There are no protocols in API for it, right?
No.
There are no, API doesn't endorse it as an acceptable industry test, does it?
No.
Okay. You didn't propose to do this originally, did you?
No.
Okay. Do you know if the JIT proposed it originally?
Not in any conversations I had, no.
Now, I want to make sure that the court understands why that might be the case. My understanding is even if there is a point at which there is a 60% nitrogen content at injection, it happens for a very fraction of a second, correct?
Yes.
And in fact, it's injected into a dynamic slurry, correct? Not a static slurry.
Correct.
Now, out on the rig, in this dynamic slurry is being pumped in a closed system, isn't it?
Correct.
And it's being pumped in a closed system that's under pressure, right?
Correct.
All right. So this test doesn't model the dynamic condition, nor does it model the closed system, does it?
No, it does not.
And nor does it model the pressure that it would be subjected to after it's being injected, right?
That's correct.
Okay. And I think you indicated earlier that you believe that pressure is one of those things that actually helps entrain and keep the nitrogen in the slurry, correct?
Yes.
And just to be clear, the 60% foam quality test was done at atmospheric, correct?
Yes.
And those three things we talked about, the fact that this is a dynamic slurry but subjected to a static test, the fact that the pressure that the slurry is seeing is not present in this test, and the fact that it's in a closed system out in the field but not in this test, those are all different points, or those are all differences between what was being done in the lab and what was actually occurring out in the rig, right?
Yes.
I know you've already verified for us that none of the compressive strength tests that were run were done on Macondo rig sample, right?
Right.
Are you familiar in the industry that when you run a UCA compressive, well, obviously when you run UCA compressive strength, you're running it on the base slurry, right?
Right.
And when you run a crush compressive, you're running it on a foam slurry, but one that's not under temperature, not under pressure, right?
That's correct.
So did you ever see any data from Halliburton where the testing pressure was 14,458 psi for UCA?
No.
All right. And I think you indicated before you just use a standard API 3,000 psi, right?
That's correct.
Now you're on the API committees and you understand that 3,000 psi pressure was not really developed with deep water in mind, was it?
No, it was not.
And in fact, the industry has kind of moved beyond API in this area, and in this effort, as you say, to try to best replicate downhole conditions in its testing, it actually tries to obtain the downhole pressure and use it in testing, right?
Yes.
And that's because you used a different temperature ramp, correct?
Yes.
And that temperature ramp heated the sample up over a 16-hour period,
Yes.
right? And you used a lower pressure, right?
Yes.
Okay. The longer heat up and the lower pressure, both of them are going to have the tendency to increase the time of compressive strength development, isn't it?
Yes, it can.
Have you ever heard of any advice on how to design a base slurry that will be foamed in terms of rheology and thickness?
Not so much about rheology, it's more about settling, a stable slurry. Yeah, you can have slurries that are thin and they're still stable and they don't settle.
Okay.
So it's not so much a function of rheology.
And can rheology also be an indication that the slurry is too thin to be used for foam cement?
No, I don't think you can say it's too thin for foam. If it's stable, and it meets other placement criteria, then there shouldn't be a problem with that particular slurry.